Hello everyone. Now we will be discussing the solutions of the part test 6 and chemistry. So with the question number 51, this was the given reaction to you. So now in this reaction you were supposed to choose a site for the attacking electrophile. So now in this question the attacking electrophile, as you know, will be the NO2 positive here. So now we have to choose which site will be there or will be suitable for the attack, as there are two given benzene ring we have. Now as we can see this, for example, this I am telling the A ring and this is your B ring. So what will happen, the A ring is more electron rich as the plus M effect of N nitrogen is there on it, but the B ring is electron deficient as it is connected from the electron deficient center of carbonyl bond. Now the attacking electrophile NO2 positive will prefer that site which is more electron rich. So it will directly go to the para position of the benzene ring which is connected to the N center, as there is plus M effect of the nitrogen. So what will happen now, this we have these two positions we have. This one is the para position and this one is the ortho position. So now we have the two options with the ortho positions and the para position. Now as on the ortho position there is also minus I acting of the nitrogen center, so we will choose the para position as it is the most acceptable position in case of the electron rich center. So we will choose the para position, and with this your C option will be correct, because here the NO2 positive group is placed on the para positions of the ring which is connected to the nitrogen. Hence the correct option will be C. This question was about choosing the site selectivity of the electrophile. Now coming to the second question, as it is asked which of the following compound will produce a precipitate with AgNO3. Now in the question it is asked that which compound will produce a precipitate. So in that case we can have C as well as D, because both are capable to to form a precipitate by giving Br negative and forming a stable carbocation. Now as it is an MCQ question, so we have to choose. So we have to choose between C and D, which will be the more better suitable answer for us, because now this position can also leave and this Br can also leave to give AgBr precipitate. Now we will decide that which position will be giving the precipitate. Now we have this compound as C. After removal of the Br negative, so we will have this carbocation, and from the compound D, after removal of the Br negative, we will have this carbocationic species. Now as we can see in the A species, the carbocation is stable by the plus H effect of these 4 hydrogens. So these are the alpha hydrogens there. But in case of B, this is an aromatic stabilized carbocation, and as we know from GOC that we prefer the aromatic stabilized carbocation are the most stable carbocation. So for that matter we will say that this B compound will be more stable after the removal of Br negative from the given options. So our plausible answer for that will be the D option. So they should have asked this question as this: the which of the following compound will give major product as the carbocationic species, but as the carbocationic species, as it will precipitate the Br negative and Ag, and hence we will get a stable carbocation for that. Hence the D option will be suitable answer for it. Now in the next question it is asked that from the among the given options, which compound will be better reactive towards the electrophilic aromatic substitution. Now we know that we have to substitute an electrophile. So to substitute an electrophile we need an attacking electrophile as well. Now the attacking electrophile will require which center? It will require the electron rich center. So now from all these benzene derivative compounds, we have to select that which benzene compound is the most electron rich relatively. So first is given as here as the Cl. and the second one is given as here as CH3, and the third one is given as here C double bond O and CH3. Now you know that for the in the among these two or three options, the CH3 will be putting plus H effect. This C double bond O center, this is highly electron deficient center, so it will be putting minus M on the benzene ring. And Cl, as we know that halogens always put only minus I, so the Cl will be putting the minus I. Now if we go by the order of the strength among these effects, so we know that mesomeric is strongest effect, and then there will be hyperconjugation, and then there will be inductive effect. Now in that manner, the plus H group will be the most electron donating group among this. So towards an electrophilic aromatic substitution reaction, this option, which is our second option, it will be the most reactive species for the electrophilic substitution reaction. So we have to find out the second option as that our first priority. So this is given in the A option as well as in the C option. Now among the first and third, we will choose basis upon the minus M and minus I. Now comparatively we know that minus M is a more strong group, and it will be affecting the benzening more than the minus I group. So what will happen, we will choose the minus I group as it will affect less the carbon electron density of the benzene ring. So what we will do, we will say that the Cl is only taking electrons from the minus I effect, but the C double bond O CH3 center is taking the electron density from benzene ring more, as it is attracting the electron density from the minus M effect. So what we will do is, we will say our now among the third and the first one will be more plausible for the electrophilic aromatic substitution reaction. So what will happen here, we will put the among the A and the C option, we will say that our A option is more correct than the C option. Why? Because as second option is there, in the second compound, what is happening, the plus H effect is there, so it is most electron dense compound, hence it will give the electrophilic aromatic substitution reactions most easily, and then after this the Cl benzene derivative, and then lastly the third option will be there. Now in this 54th question, it is from thermodynamics. As you know that the combustion of isobutane they have asking, so first of all we will write the equation for the reaction. Now we will say the C4H10. Now in the question itself it is given that it is a gaseous reaction, so we will take all the products in the gaseous state, reactants and the products in the gaseous state only. So what we will get is CO2 plus H2O. After balancing it, we will get 13 by 2 O2, and we'll get 4 CO2, and we'll get 5 H2O. Now all these reactants and the products are in the gaseous state only. So first of all, we'll find out the del Ng value. What is del Ng? Del Ng is the difference between the number of gaseous moles in the products and the reactants. So we will get 4 plus 5 minus 1 and minus 13 by 2. So what we will get solving it, we will get 3 by 2. After this, what we will do, we'll use this equation of the enthalpy and the energy, the del U plus del Ng RT. Del U is nothing but del U is del E only, that it is the internal energy. In question it has been used as del E, or in the general convention we use a del U. So now for the del H value, what will happen, del H is equals to del U plus 3 by 2 RT. Now we know that del H is equals to del U with the addition of 3 by 2 RT. Now R is a constant, it is a positive quantity. Temperature also is a positive quantity. So there will be some value adding upon in this del U plus 3 by 2 RT. Hence del H has to be greater than del U for this reaction to happen. Hence we can say that the B option will be the correct option for this reaction to happen, and it will be the correct condition for the reaction to take place. Now in the 55th question, what we will say, enthalpy change of a reaction will be equal to. Now, just in the previous question, we have solved this question as del H is equals to del U plus del NGRT. But as you know, the origin of this equation is from this equation, which is del H is equals to del U plus del PV. And why so? Because as we know, for an ideal gas, we can say PV is equals to nRT, and we can say del PV will be equals to del nRT. So from this relation we can say that we will get the relation as the del H is equals to del U plus del PV. Now why del PV? Because at the constant pressure we will say P del V, and at the constant volume we will say V del P. So both the equation can give you the value of the del H. Hence we will say the enthalpy change of a reaction will be equal to del U plus del PV, which is given as the C option here. So the C option will be the correct answer here. Now again for the 56th question, what is given? Calculate the work done when 50 gram of iron reacts with HCl in an open beaker at 25 degrees Celsius. Now what is given to us? First of all, we have to calculate what? Our work has to be calculated. What is given? The mass of the iron is given as 50 grams. Now temperature is 25 degrees Celsius, or I can say 298 Kelvin. Now after this, what I can do? Now the reaction for the Fe reacting with HCl, as you know from your organic, that Fe in the solid form reacting with HCl aqueous form will give you what? It will give you FeCl2 aqueous plus H2 gas. Now balancing this equation will do 2 HCl. Every other element is balanced here. So what we can say, the 1 mole of Fe, it will give you 1 mole of H2 gas. So can we say, now calculating the number of moles of Fe, what we will get? We will get 50 by 56 moles. Now we have to find out the work done. Now work done, we know that work done will be is equals to minus P external and del V. Now we'll say, sir, why it is being used as the P external del V? Because see, it is given as the open beaker. Open beaker means whatever is the expansion, whatever is the work done is happening, there is no external pressure acting upon. So it is there is no additional external pressure working upon it. There is just atmospheric pressure on it. So can we say minus P external del V? Here the P external will be the constant and del V will be there changing. So now for del V, what we can say, from using the ideal gas equation, we can say that del V will be is equals to nRT upon P external, and by this P external will cancel out each other and it will be minus nRT. Now number of moles is, as we calculated, is minus 50 upon 56, and we will get R as 8.314, and this will be 296. Now guys, in thermodynamics, always mention the units with it. For example, this 298, it will be your Kelvin. This 8.314 will be what? Joule per Kelvin and per mole. Now 50 by 56 is mole. So Kelvin will cancel out Kelvin, per mole will cancel out the mole. So we will be left with the joule, which will be our answer. So work done will be in the joules only. So solving this question, you will get the answer as 2212.11 joule. So which is your B option. So the correct answer will be minus 2212.11, we can say, or we can say 2 approximately joules. Now in the 57th question, when 1 mole of monoatomic ideal gas. So first of all, always write what is given to you, first especially in the physical chemistry. So the number of moles are given to you as N is equals to 1 mole. Ideal gas at initial temperature. So initial temperature I'll represent by Ti. It is T Kelvin. Now another thing is adiabatic process is there, and the V2 is 2 liter and V1 is 1 liter. Now find the final temperature. So we have to find out the T final. Now we know that if the nothing is given to us, we will consider the process as the reversible process for the in the case of specially adiabatic processes. Now the thing which is given to you, it is a monoatomic ideal gas. So for monoatomic gas, we know that the CV value for the monoatomic gas will be 3 by 2R. Especially similarly CP value will be for it 5 by 2R. So gamma value will be left as 5 by 3. Now why I am doing this? Because for the reversible work done in adiabatic process, we know that for the reversible we put this V minus P del V is equals to NCVM dt. So we say that work done is equals to del U. Del U is NCVM dt, and if it is a constant temperature, then the internal energy is not there. But if it is not constant temperature, like not an isothermal process, so it will be minus P del V is equals to NCVM dt, and there will be heat energy also on the side of the work done. Why? From the first law of thermodynamics, you know Q plus W is equals to del U. Now as the process is adiabatic, so Q will be 0. So what we will say, Q will be 0 here. So after this we can say Q is 0, so W is equals to del U. From this you can solving this, integrating this, as you know, this will be turning out to the P1 T1 V1 gamma minus 1 is equals to T2 V2 gamma minus 1. So here in this case we have to find out the T final, or I can say T2 here. So T2 will be T1 V1 gamma minus 1, and it will be V2 gamma minus 1. Then answer will be T1 upon 2 to the power 2 by 3, which is given as the B option. After this we will come to the 58th question, which is given as the based on the following thermochemical equations H2O plus C. These are the two equations given to you. So these are the two equations given to you. First one is this, and the second one is this, and the third one is H2 plus half O2. Now you know that to get this fourth equation, what we will do is, to get this fourth equation, what we can do, we need carbon and O2, 1 mole of O2 and 1 mole of carbon in the solid form at the reactant side, and we need the CO2 gas at the product side. So we need nothing. Now can we do one thing? This is the first equation, this is the third equation, and this one will be the second equation. So what we can do, get this final reaction fourth, what we can do is, fourth reaction will be given by all these reactions if we add them together. So we'll get the fourth reaction. But how we'll get, for example, adding, if I write H2O plus C giving you CO plus H2. Second is CO plus half O2 giving you CO2. Now H2 plus half O2 giving you H2O. So now summing them, the 1, 2nd and 3rd. So summing them, we will get as H2 will be cancelled out H2, H2O will be cancelled out H2O, half O2 and half O2 will be 1 O2, and CO will be cancelled out by CO. So we will get CO from here, 1 O2 from here, and this will be CO2. So C plus O2 will be giving you CO2. Now, so basically we have added the reactions. So what we will do? We'll add up, sum up all the del H values given for the first, second and third reaction to get the del X value for the fourth reaction. So after adding up with their signs, we will get, for example, so what we will do? We will do as 131 minus 282 and minus 242. So solving this thing, we will get as the minus 393 kilojoules per mole will be the answer. So which is your C option. So the next question now is the 59th question, and in which the dissociation energy of CH4 and C2H6 are given into their gaseous atoms. So guys, it is the gaseous atoms. So now we have to look out for example, if we have CH4, so there are 4 CH bond here. So if there are 4 CH bond, it means for the complete CH4 molecule it is 360 kilocalories and per mole it is. So for per CH bond I can write as, for the per CH bond I can write as the 90 kilocalorie per mole, because there are 4 CH bonds in the CH4 molecule. Now in the C2H6 what is there? There are 6 CH bonds and there is 1 CC bond. Now the total dissociation energy that we require for C2H6 to convert into the gaseous atom is 620 kilocalorie per mole. So now we have to find out the bond energy for CC. So what we can write? We can write that the bond energy for CC plus 6 into bond energy for single CH bond must be equals to total 620 kilocalorie per mole. Now for single CH we know that it is 90 kilocalorie per mole. So for single CC bond we will get what? 620 minus 6 into 90. So we will get as 540, and after solving this we will get 80 kilocalories per mole. So which will be option D. Now the 60th question. In the 60th question what is given to you is that if 75 grams of water at 30 degrees Celsius. Now before this question you must know that heat capacity of water. So I will write the heat capacity of the water, specific heat capacity rather specific heat capacity for water is 4.18 joule per gram and per degree Celsius. Now in terms of calorie it is 1 calorie per gram and per degree Celsius. So it is the specific heat capacity for water. Now what is given to you? Now the formula for the specific heat capacity is Cs is equals to Q upon M delta T. So what will be there? Cs is, as we know, 1 calorie per gram per degree centigrade is equals to Q we have to find out, and the M mass is given as 75 gram plus delta T, change in the temperature we have to find out. So if the change we have to find out, then it will be, for example, let's say T2 is the final temperature and 30 degrees Celsius is the initial temperature. Now Q value see 75 gram of water at 30 degrees Celsius absorbs 900 calories. So 900 calories are the heat energy absorbed and Q is the heat energy absorbed. So what we will get? We will get Q is equals to 900 calories. So after solving this we will get T2 is equals to 42 degree Celsius. So the answer will be A option. After this now 61 question. So 61st question में क्या है? 8 gram of O2 gas at 27 degrees Celsius is compressed to half of the volume under isothermal and reversible condition. So first thing that we have to mention is isothermal process is there and it is a reversible condition. Now we know that for isothermal reversible process we know W is equals to minus nRT ln V2 by V1. So from the question given we can say that first of all number of moles of O2 is 8 grams upon 32 grams per mole. So answer will be 1 by 4 here and mole. Now we have to find out what? Temperature. Temperature is given as 27 degrees Celsius. So it will be 300 Kelvin. Now after this what is there? After this let's say V1 is the initial volume. So V1 is the initial volume, it is as 1 liter. So for example if it is 1 liter, so V2 will be what? V2 will be half of the volume. So it will be, I can say, half liter. So solving this what we will get? So work done will be is equals to minus 1 by 4 mole multiplied by 2 calorie per mole per Kelvin. The R value here we will be using is in the terms of calorie. 300 Kelvin into ln 0.5 upon 1. So solving this we will get as the minus 2.303 into 150 log 2 we will get, because so log 2 we will get. Now if we have to put this as log 2, so what we are doing, we are taking this 5.5 upon 1, we are reversing it. So after reversing we'll get the answer in the positive sign, and which is also correct thing. Why? Because the compression work in the isothermal process is always positive. After this is a 62 question. So temperature for 1 mole of a gas is increased by 1 degree at constant pressure. So work done we have to find out. Now for this question what we will say, as we know that it is a constant pressure, so which process it is? It is isobaric process. So for the isobaric process, work done is minus P, which is external, we can say constant pressure, so it will be V2 minus V1. Now for isobaric process, we know that T1 upon V1 is equals to T2 by V2. And why so? Because PV is equals to nRT. If P is constant, what we can say? N and nR is also constant, so we can say nRT upon V is constant. So from here we can say T and V, T by V, T1 by V1 is equals to T2 by V2. Now how we can solve? For example, now let's say if temperature has to be raised by 1 degree only, so we can say if T1 is equals to T, so T2 has to be T plus 1. So now and V1, let's say V1 is V your. So what will happen now? We have to find out V2. So what we will do? We will say T1 V2 is equals to T2 V1. So what will be there? T is there. T1 we have considered as T, and V2 is the V2 is equals to T2 now is T plus 1, and V1 is your V. So after solving this, you will get as V2 is equals to V plus V by T. Putting this term into the initial equation, what we will get? We will get as W is equals to minus PV by T. Now we know that minus PV by T is also equals to what? Minus R for the 1 mole of the reaction. So W will be equals to minus R. So answer here will be A, but it will be minus R, not the plus R. This has to be corrected. Now in the question number 63, what is given to you? For A to B, del H is equals to 4 kilocalorie per mole, and it is not del H, it is del S is equals to. Why so? Because as the units are given to you, so you have to, in thermodynamics, you always have to go for the units. What is the units given to you? You will decide on that basis that what is the condition or the state function or any other variable given to you. Now this del S value is given to you and del H value is also given to you. So what is asked, what temperature the reaction is spontaneous. So the reaction will be spontaneous, we have to find out. So first of all, let's talk about the equilibrium condition where the del G value is 0. So using this del G value is equals to 0, we will say the del H minus T del S is equals to 0, and by that we can get T. So T will be what? Del H upon del S. Now del H is equals to how much? 4000 calories per mole, and del S will be your 10 calorie per Kelvin and per mole. So what will be answer then? Temperature will be 400 Kelvin. Now this temperature is for what? This temperature is for equilibrium condition. Now where the del G is equals to 0. So now if we increase the temperature more than 400 Kelvin, then only our process will be spontaneous. Otherwise it will be at equilibrium. Now for the spontaneous process, we have to choose the option in which the temperature is given as the more than the 400 Kelvin. So this option is the C option in your from the question. Now in the 64th question, what we will do is, the 64th question, the Clausius-Clapeyron equation is given to you. So now P is equals to, Clausius-Clapeyron equation is P is equals to A into E minus del H by RT. Now taking the logs both side, what we will get, log a, p is equals to log a minus del h by rt, and it will be log e. Now the log e, as you know, is 0.4342, so it will be a 0.434, let's say. So it will be 0.434. Now by from the given equation, this is your given equation, and you have to just compare it with our required equation. So now log a value will be what? Log a value will be, by comparing this equation with the original equation, log a value will be equals to 10, where the a value you get is what? The a value you get is 10 to the power 2, because a is equals to antilog of 10, and antilog of 10 will be 10 to the power 10. Now after this, what will you get? You will have to check for the del h value. So now for the del h value, what is given to you? Minus del h into 0.4342 upon rt, and what it is equal to? It is equal to minus 4000 upon my temperature. Temperature will cancel temperature, negative sign will cancel negative sign. So what will you get? You will get, solving it is 2.303 into 4000 R. So the a value is 10 to the power 10, and the del h value is 2.303 into 4000 into R, which is given in the C option. Now here in the 65th question, what is just a simple question? Density is being asked to you. As you know, density is equals to mass per unit volume. So if the volume is same, so more the mass will be there, more will be the density. Now in the D option, it is Br and Cl is there. In the C, Cl and Cl is there. So which is the more dense, like which has the more mass in the compound? So D is having the most mass in the given compounds, and then C, then B, and then A. So this will be the final order for the density also, that the D will be the most dense and A will be the least dense. Hence the A option will be correct for you. Now in the 66th question, what is given to you is, which one of the among the following resonating structure is not correct? Now from the duals we know that the two positive or the two negative, it means the similar signs cannot bear the adjacent center. But this rule is being violated in the A option, where the N is also having positive and the carbon which is adjacent to N is also having positive charge, which will be most unstable structure. Hence we will say that it is not a correct structure. For the 1867th question now. See, in this question what is given to you, this was the question. It will be going through the carbocationic mechanism. So first there will be a formation of carbocation, which will be like this. Now here we have hydrogen. So what will happen? That there will be this hydride shift. So this will be the hydride shift here. So the positive charge will be now stable, because it has 3 alpha hydrogen here, and it is 2 alpha hydrogen here, and it is 2 alpha hydrogen here. So what will happen? It is a more stable carbocation. So now this B option is also getting formed, D option is also getting formed. But now we have to check about what? The C and A option. Now after this step, the H2O will attack. Oxygen is having lone pair, so it will attack here. So what we will get? We will get as OH2 positive, because oxygen cannot make the 3 bonds. So now H positive will leave, and we will get the answer as the desired. So this will be the answer. So now C option is also getting formed as an intermediate. So only the A option is the intermediate, which will not be present in this reaction. Now for the 68th question. Again, this question was purely basis upon the substitution reaction. Here, as it is the benzylic carbon, so it will be going through the SN2 mechanism. Now we know that the Br, which is directly attached to the our benzene ring, will not be that much susceptible for the nucleophilic substitution reaction. But CH2Br, the Br which is here on the presence on the benzylic carbon, will be more susceptible for the SN2 mechanism, and it will give you the SN2 mechanism by substituting the Br, and NH3 will substitute the Br. So the final product we will have will have without any interference of the Br which is attached to directly to the benzene ring. So we will get the A option as the correct option here, where the benzene ring on the where the bromine on the benzene ring is not disturbed. Now after this, now the 69th question. In the 69th question, what is there? In the 69th question, what will happen? That we have to check about the SN1 reactivity. For SN1, we know that there should be the stable carbocation should be there. Now among the stability of the carbocation, let's draw this carbocation which will be forming here. So it is Cl. So it will directly give you this. It will be a 1 degree carbocation. For second, it will be your allylic carbocation, and in the third option it will be a 2 degree carbocation. So now as we can see, the most stable carbocation is the allylic carbocation, so it will be most fastest towards the SN1 reaction. So we will say that 2 is the most faster in the towards the SN1 reaction. Again, among the 1 and 3, the third one has having the 3 and for the 2 5 alpha hydrogen, and the first one is having only the 2 alpha hydrogen. Hence the third one is more stable carbocation. So it will be 2, then 3, and then it will be 1. So it will be the D option there. Now as you can see in this reaction that it has been asked for the energy profile diagram is given for the exothermic reaction. Now they are asking the rate determining step. Now among the rate determining step, about the rate determining step, you know that the rate determining step is the step in which you have to provide the maximum energy, or where the activation energy barrier is the highest. So we know that from going from A to B, the activation energy barrier is the highest. So we will say that this is the rate determining step for the following or the given reaction or the process. So hence the rate determining step of the reaction is from A to B. Now we'll talk about the 71st question. Now in the 71st question, what is given to you? First of all, the latent heat of vaporization. So I vaporization will be is equals to 10,000 calorie per mole. Temperature is and pressure is 1 atm here. So what they have been asking you is the change in internal energy for this. So del U we have to tell about here. Now the only thing, the formula that we will be using here is del H is equals to del U plus del PV we can use. But now no, volume is not given to us. We cannot find the volume. But can we find the del Ng value so that we can substitute it by del NgRT as well? So what we will do, we'll write latent heat of vaporization. So this process given to you is the vaporization process. For that, this will be here. So for this reaction, the del Ng value will be what? 1. So the del Ng is 1. So we will get as del U is equals to del H. What is del H? 10,000 calorie per mole, and minus it will be, what is del Ng now? Del Ng is 1 into 2 calorie and it will be 500 Kelvin. So solving this, you will get the 9 kilocalorie per mole here. So the answer will be the, in the terms of kilocalorie, so in the terms of kilocalorie it will be 9. Now in the 72nd question, what is given? The del H T values are given for you for the CO2, CON2 and NO2. The del H value for this reaction. As we know, the del H value for the reaction del HR is equals to H for the products minus H for the reactants. So we have to basically do this only. Now we know the reaction. Now you see these are the del H value given to you. So they are in terms of per mole. Like for single mole, this much of the kilojoules of the energy will be required. So now in the balanced equation, if we are given as the 2 mole, 3 mole or whatever the moles are given, we have to multiply that numerical value from the number of moles, so that we will get the kilojoule, or we can say the total energy for that much number of mole. Only this thing has to be taken care in this question. So what we will say, 81 is for what we say, 81 is for N2O. N2O is having 1 mole, so it will be 81. Then minus for CO2, it should be 3 moles, so it will be 3 into 393. Subtracting for the reactants now. So reactants is 3 moles of the CO gas. So what will be there? 3 into minus 110, and then it will be plus 2 into, there are 2 moles for the NO2 gas. So it will be 2 into what we can say 34 here. So solving this we will get as the minus 836 kilojoule per mole, which will be the answer here. So now in 73 question, see in 73 question what is given to you, that we have to do the dihydration of 2,3-dimethyl butane 1-ol and treatment with the concentrated H2SO4. So now what will happen is, first we have to draw the structure of the 2,3-dimethyl butanol के लिए. So for butanol it will be like this, Me, and this will be your OH. So this is the given compound. Now they are treating it with the what? Concentrated H2SO4. So concentrated H2SO4 will give you H positive. Now H positive will attack where? At the lone pairs of the oxygen. So it will be now, in the next step it will be what? It will be your OH2 with a positive sign. Now H2O will leave. If H2O will leave, so what we will get? We will get the intermediate as the carbocation. So we will get this thing as Me, and we will get this as the positive, and here is hydrogen. So this is the intermediate that we are getting from the reaction. So now this elimination will be happening. Now either elimination can happen directly, so this hydrogen can leave and there will be terminal alkene. Now if there can also be possibilities of what? There can be possibilities of what? This reorganization or the rearrangement of the carbocation by the hydride shift. So we can get these two things, actually 3. So now first thing we can happen is, so now for the 72nd question, what we have to do is, you are provided with the del H values for the every compound present in the reaction. So as we know that the del RH value, which is the del H value for the reaction, is equals to del H value for the products minus del H value for the reactants given to you. So what we will do, we'll sum up the del H value for all the products and we'll sum up the del H value for all the reactants. But one thing that we have to mention here is that this value are given as the per mole. So these value are given for only 1 mole. So wherever there are number of moles more than 1, we have to multiply by the number of moles also to get the exact value for the del H for any that particular compound present in the reaction. So for example, first of all we write for the product. So it will be 3 into minus 393 for the CO2, then plus for N2O. For N2O it is 81. So now minus for the reactants it will be NO2. So it is 34 into 2 and it will be plus for CO it is for CO it is minus 110. So for the 3 moles of the CO it will be minus 110 into 3. After solving the complete this thing, we'll get as minus 836 kilojoule Now it will not be per mole, because it's anymore it is not the per mole, because we have already multiplied by the moles. So we will not say it is per mole, so the answer will be in the minus 836 kilojoules only. Now for this question, the compound given to us is so now the concentrated H2S, so far as you know, will be providing H positive, and H positive will be attacking on the lone pairs of the oxygen. So on the lone pairs of the oxygen, OH2 will be there, OH2 will be leaving. So the intermediate species that we will get is OH2 positive. So now OH2 positive will leave, and we will get the compound is like this one. So now after this, what will be there will be two alkenes can be there. So one alkene can be without the rearrangement of this carbocation. So then this answer will be this one without the rearrangement. But if to have the rearrangement, the first path is this and the second path we are following here. So if there is a rearrangement of the carbocation by the hydride shift, so what will happen? There is this hydrogen, so what will happen? This hydrogen will go there, and what we will get? We will get as this one as the okay, so we will get this as the this hydrogen will be here. So from here, what two alkenes we can get is this one. So one alkene is this one and second alkene is this one. So we'll get the total number of isomeric alkenes from this compound given is the 2. So after this, the 74th question. So now it is given as the monohalogenated possible product we have to tell. So the simplest optically active alkene will be first we have to draw the simplest optically active alkene. So that will be H2Ni. So first of all, as we know, H2Ni will do what? Hydrogenation of the alkenic bond. So we will get what? C single bond C, and we will get hydrogen here, and we will get CH3 here and CH2 CH3 here. So what we will get is, now we have to react this compound with some Cl2 HCl. So we will get what? Replacement of the hydrogen from the chlorine. So now how we can get this thing? Because first of all, after H2Ni we will get the alkane. After the alkane, what will be happening? There will be substitution of Cl negative on the Ne of the hydrogen. So how it will happen? How many plausible hydrogens we have? So now first compound that we can get is this one. So now it is only one. Now the another one that we can get is this one, and the last possibility for the reaction is this one. Now as we can see that this is the stereo center. So after the stereo center, as this is the stereo center and there is no POS and COS in the compound, so total number of isomer will be 2 to the power n. So there is 1, so it will be 2 here, and there are the 2 center here, so it will be 4 here. So after this, what will happen? Now the another possibility left is the last possibility that I am drawing here, that it can be happening like this also, like CH2 is here and Cl will be go here. Now there is no stereogenic or stereo center in it, so there will be only single isomer. So 4 from here, 1 from here, 2 from here and 1 from here. So it will be 4 to 6 and then 7 and then 8 monohalogenated organic products are following, including the stereoisomers in this reaction. So in the last question, what will be happening is, in the 75th question, now this is a Birch reduction reaction, Na in presence of liquid NH3. There is a selectivity for this reagent. What it does alkenes to alkynes. Alkynes to alkenes it do, but only for the only for the internal alkenes, not for the terminal alkenes. So it will do only for the internal alkenes, not for the terminal alkenes. So at the terminal alkenes, what happens, for example, if you are provided with the first example CH, so this hydrogen is enough acidic, so it is enough acidic here, and it will leave the compound as C triple bond C, and it will be negative charge which is very much stable on the sp center. So what will happen, it will be like this, then Na positive will be there, and it will be CH triple bond C Na for the terminal alkene. And for the internal alkene, what will happen, for example, you are provided with CH3 C triple bond C CH3. So here what will happen, Na NH3. So Na is the metal. What it will do, it will give the electrons. So after giving the electrons to the this alkyne bond, what will happen, this will be CH3 and it will be CH3 H and H. Why I am drawing the bonds like this, because it will be the trans alkene rather than a cis alkene. So NaNH3, always remember, it gives the trans alkenes rather than the cis alkene, and it only gives reaction for the internal alkynes, not for the terminal alkynes. Now the one question that was left is, so the one question which is left is, #66th question. Now in the 66th question, what will happen is,